Okay, so in our previous class, what we have done, we have designed the bridge for interior strip, and now you have designed your same bridge for the exterior strip. So let's conclude. Conclude in a sense, let's draw the cross section and plan view of the bridge. But before that, what I need the steel. The following steel. Number one, distribution. The main steel for interior strip. How much is that? Tell me the spacing.
The main steel
is 2,000.
Spacing. Number 10, number 25 at the rate of
25.
Number 25 at the rate of
200.
200. For interior.
interior. 150.
150.
Okay. And similarly, the main steel for exterior.
25 at 200.
Okay. Center to center. Next is the distribution steel.
The first one
Interior.
was
interior كم طلعت
Interior 190.
13,
13, 190.
190.
Spacing.
Yes.
190.
Distribution steel for interior.
190.
Number
13.
Number 15 diameter.
number 13.
Yes.
And what about the distribution steel for
Exterior.
exterior?
Number 13 at
156.
256.
Number 13 at the rate of
256.
256. Okay, round it to the low multiple of 10.
50.
Yes. And what other? Shrinkage steel? The third steel was the shrinkage and temperature. This is AS minimum.
Yes.
Well, we already checked it. So we have two steels. One is the main steel and one is the distribution steel. So for the main steel we have number 25 at the rate of 120, and for the distribution steel it is like number 13 at the rate of 190. Okay, so what we do now, this distribution steel will be placed at the top of main steel. There is one more steel which we found, that is the shrinkage steel. Shrinkage. That is the third AS minimum, shrinkage and temperature steel. Shrinkage and temperature reinforcement. We found it last time. For interior, how much is that?
Distribution.
It is after distribution.
Cross area.
This one is first payment.
Okay, for previous one,
It's 676.
this
676.
is the spacing. We did not find the spacing.
We found it.
If you just show me the points, yes.
It's minimum we didn't find only for distribution.
For distribution, and then we find AS minimum top and bottom. See, we find AS minimum for top and bottom steel. This is what I was saying. This is 0.75 over 2 Ag over Fy less than or equal to 50%, 401. I know this is the AS minimum for distribution, I know that. But at the top we don't have any steel. All these steels what you have mentioned, like these steels are the bottom steels. Because it is the simplest supported beam, so the main steel will be placed at the bottom of the slab. And the distribution steel will be placed at the top of main steel to form the cage. Okay? But what about the top layer, top side?
Compression.
It's compression, you're right. But there we need steel to control the shrinkage. And that is again the same AS minimum for shrinkage which you have already calculated in the previous class. And that was 401.8 millimeter square per meter. Okay? 401.8 millimeter square per meter. And you can find the spacing, or you can use like number 10. Yeah, for example, the steel was 400 millimeter square per meter. If you use number 10, give me your calculator. I will do it quickly for you. So 401 1000 into 71 over 401. So it is number 10 at the rate of 177, and if you use number 13, it will be number 13 at the rate of 200. This is the shrinkage steel. Your distribution steel should be greater than this value. Your main steel and distribution steel both should be greater than this value. But we also need this steel at the top, because at the top we don't have any steel, and in order to control the shrinkage we have to provide this steel. Okay?
For the space, you take the same space as distribution.
It is number 13 at the rate of, what was the answer? So 321, sorry. It is 320, not 200. Yes. This is the AS minimum for shrinkage. We calculated in the previous class, but you were not able to finish in today. So this is what we are going to use for the top. Okay? Let's go next. First let me draw the cross section of your bridge. How will be the cross section? So this is the footpath and then barrier. So this is a total cross section of your bridge. Let me show you the dimensions. So this one is
10,000.
1200, and then 1200 and 600. This is the width, and then again 600, and then there are 2 interior strips, and this total dimension is how much?
So give me this one.
So it is 3214 and 3214, so it is 6428. Okay, this is the exterior strip, and then 2 interior strips. The drawing is not on scale, but I know you can understand. This drawing is not on scale. I mean, this should be a little bit more lengthier than the exterior strips. Okay. How we will place the bottom steel? Now, we have 2 strips. This is the exterior strip, and then we have 2 interior strips. I have just made them separate. So, how should be the placement of the steel? Which steel should be at the bottom?
The main.
The main. Which way?
And
I mean, I should draw like a circle, or I should draw like a line?
Line.
line.
Line. Where is the support? Where is the support?
Like this.
Support is here. Your bridge is going this way.
Like a pole.
Accept.
Yes.
Right.
It should be like. So here we have the bottom steel of the. Again, this number of bars does not reflect the real condition, but the total number of bars, the number of bars will be more, but I will show here the spacing. The same way here. This is at the bottom. And then, what about this? It is the interior strip steel. Again, the main steel is at the bottom. Now, this steel spacing is different from the interior. How much is the spacing of this steel?
It's 200.
This steel spacing, you can write it here. Number
200.
200.
Number 20, 25, 200.
the same way this one. Number. Okay. Now
For the interior.
we will for the interior it will be
25, 150.
number 25 at the rate of 1. If this difference is small, like number 25 at the rate of 190 or number 25 at the rate of like 160 and it is 150, you can provide the same steel throughout the strip, okay? But if the difference is significant, you have to separate the 2 steels. Now, how will be the distribution steel? Distribution steel will be placed at the top of this.
As a line.
It will be as a line. Okay, so let's show the.
As a best. Make it hard. Touch the logo.
You know what? For the distribution steel, listen please, it is an important point. It is a practical point or the detailing point of view of your bridge. For the distribution steel, now if you see, we have number 13 at the rate of 190 for interior and number 13 at the rate of 250 for exterior. So if you do that, you are going to make 3 gauges. 1, 2 and 3. 1 and 2 or 3. Do you understand?
Yeah.
Because this gauge, the spacing of the steel is different, and for the central gauge, the spacing is different. I would prefer you should make a uniform gauge. Although the spacing of the main steel is different for bottom steel and for the top steel. For the exterior and interior strip, but you can put the same distribution rebar throughout the length and provide
250.
number 19 at the rate of 190. You know what is happening? For the center we need this. We need for the interior strip this steel we need number number 13 at the rate of 190.
Yes.
And here we need number 13 at the rate of 250. But it means we have to break the bar. Do you understand or not?
Yes.
We have to break the bar, which I don't prefer. So what I'm recommending to you, use this number 13 at the rate of 190 throughout the length.
Make the space small and
So it means it is a uniform gauge.
yeah.
Do you understand? If you understand, it is very good. It is a practical point of view.
And it will not be costly because the area is small, not so much.
Yeah, in a sense you're right.
But for the design, so to save them time, we design only for one, for interior or exterior. For the, I mean, for distribution.
I did not understand your question.
I mean, you want to make them, all of them in the same space, right?
You can have the time for discussion. If you want to discuss, I can give you some time, or you can ask it from me. Yes. What is your question exactly?
For the space, we got two different space for distribution steel, for the exterior and interior.
Yes.
And what I understand from you, we have to make them uniform for the space.
Yes.
So we have to design only for one, either exterior or interior.
No, we have to design for both, but we have to provide
Choose the
the which has lesser spacing. Now for the top is very easy. Top is very easy. You know what? For the top case, how you can do that? We have this spacing number 13 at the rate of 320. And if you see, we divide it by 2 because we are providing the total steel into 2 layers, top and bottom. The actual number of steel is 401 into 2. So that you can make a cage at the top. You can provide any way. For example, either you can place these bottom bars at the top, or for example, either you can put it this one or this one. No difference because it is a uniform spacing. And it is a shrinkage steel, it has to do nothing with the span. So anyway, it is fine, you can just or provide this way. And this steel, both of these, bottom and top, it is number 13 at the rate of, well, if I'm really providing, I will make it 300 because 300 is a good spacing. Like many, you can find it's easier for the labor to put at every 300 because we have standard scales for 300 mm, okay? Or 320, whatever you like. If you want it to be 320, you can make it 320. So this is how you can show the reinforcement, the main reinforcement of your bridge. Now about the barrier and about the footpath, there are some minor details. The barrier reinforcement details, for example, we have a standard barrier, and I will share these details with you. Maybe I will send you the notes, or you can find it in Astro. The standard reinforcement details for the overhang or for the barrier. I will show you this in my upcoming lectures, because once we are going to the reinforced concrete girder bridge. So in girder bridge again we have the barrier, and in that case we have to show this part as a separate entity. So in that design I will show you in detail the reinforcement details of the barrier and the footpath. We call it overhang in that case. So do you have any question in it?
Just about humidity and temperature.
Yes.
Both ways.
Yeah. We are providing in the both ways. Because this is the steel for one layer. This is the steel for one layer. If you see your notes.
Was 800 to divided by 2.
Yes. The total steel was 800, but we divided that by 2. Okay. we have done with the cross section. Now let's go to the plan view of the bridge. So I'm going to erase it, okay? Okay, I just erased this part. Again, the plan view is not on scale. I'm not going to plot the plan view on scale, but please see here. Now the traffic is moving from up to down, or you want me to draw like this? Which way? You want to draw the plan view like this?
Which is easier to read, Victor?
The same as the
I think
The top view.
the top view at the
Yeah, if you talk about, you mean the barrier like this or the
Yeah.
barrier like this?
No, at the right and the left as the below. So we can.
You're right. But for that I need the bigger space. It is just like the top view of this. But that is not on scale. For example, this is the barrier.
Victor, we have to show the steels and top view also.
It's better. Okay, slide please. I hope you have studied the detailing of the bridge in the detailing of the slab in reinforced concrete design. Did you study or not? The reinforcement detail of slab. How to put the slab reinforcement. So this is the, and then I show the footpath. This is the footpath on the left side, and this is the footpath on the right side. And then your exterior strip, for example, this is just a dimension line. This line is a dimension line. Your exterior strip is still here, and then you have two interior design strips. Okay, now how we will show the steel? We will show first the main steel with a solid line, and then from this point to this point we will write the spacing. How much is the spacing?
I think it's 150. 150.
This steel is how much?
150.
This is number 35 at the rate of 150. So you can write here number 35 at the rate of 150. And what about this steel? How much? You can show a rebar. Okay, what I'm doing for the easy and for the convenience, I do not show the footpath because you can otherwise you can misjudge or miscalculate. For example, this is the exterior strip. So I'm going to show the reinforcement of the exterior strip. Okay, how much are these dimensions?
1.8 at the exterior.
1800, 6428. So how much is this? Number 25 at the rate of. So this steel is number 25. This steel is also number 25 at the rate of 200. And now this is the bottom steel. Above this we have, above this steel we have distribution steel, and this distribution steel is spanning full length. This distribution steel is present the full length. And how much is the spacing of this distribution steel?
190.
Number
13, 190.
number 13 at the rate of 190. Did you understand? I just shown the two steels. One is the bottom steel, other is the distribution steel on that. And now, how to show this steel? Shrink steel. We show the shrinkage steel by dashed lines. We show the shrinkage steel because it is at the top, and the top steel is shown by the dashed lines, the reinforcement detailing. I should have one more color, but unfortunately I don't have. Okay, I'll just show it here. So this is one bar, and this is the other bar. And for both of these, you can say the spacing is this one, number 13 at the rate of 320 or 300, whatever you like. And for this again, number 13 at the rate of 320. So this completes the plan view of your bridge. How you can show the depth of the slab by this 450. And you can also show the total depth of the slab here. For example, I'm just going to cut the dimension line, which actually is not correct way. Anyhow, please let me do that. This is the 450. This is 150, and this is I think 1200. I'm not sure how much is the height of the barrier.
I think 300. No.
1200, I think. Sorry, 865. 865 minus 600 is 325. 865 is the total. So 200 and
I think 265.
just keep it 325 minimum. I think it's reasonable to have this much barrier. Okay. So this concludes the design of your slab bridge. And in the next lecture, we will study the design of reinforced concrete girder bridge, in which we will be having girders at the bottom of slab. And the good thing is that those girders will be the part of slab, like a T-beam. It is easier to design the simply supported girders like the other I-shaped girder, but that girder which we will solve in this class will be more difficult and more challenging. Okay, any question?
About the distribution steel, we take it as a uniform, as a cage, one cage.
Yes.
Why we didn't take it for the main as the same?
We can do that, but it will be expensive.
Because
The main steel is number 25.